I found this incredible 80s vintage Keytar on eBay, sold for spares and repair, and I'm gonna see if I can get it working and back to its former glory. So let's see how I get along in this retro repair. Machine, the Korg Remote Keyboard RK100, also known as a Keytar, which is obviously a contraction of keyboard and guitar, sometimes known as shoulder keyboards. I don't think that ever really caught on. These days they're much more widely referred to as a Keytar. Ridiculous name. So this one came out in 1984, which is my favourite year in the 80s, obviously the best year of the 80s. If anyone wants to argue with me, please feel free to leave a comment. So yeah, I got it off eBay completely for spares and repair. The guy had no means to test it, so he didn't know whether it worked or not. Now, I've plugged it in, I get the lights come on, but no MIDI comes out at all. It's just like none of the buttons do anything. I mean, it's literally just the lights come on. So I don't know, I've got no idea whether I'm going to be able to fix it, but I'm going to have a damn good try. And of course, the first thing I'm going to do is take it apart. This metal panel here is a bit loose. I'll have to look into that later, but let's just lift this whole thing out and see what we've got. Right, well, it's pretty filthy. There's a lot of dust and crap in there. Check some of these wire connections. They all seem pretty sound. That connection there, that earth connection there, is looking a bit thin. And it's interesting. So I think that's standoff. It's weird, but I think that's meant to be attached to the metal there. I don't know if you can see that. That's loose. That's all a bit strange. So I can see a few bits of fluff and dust. I mean, it's surprisingly complicated, really, considering it's just a dumb MIDI controller, but I guess back then we didn't have the same sort of microcontrollers that we have now. So maybe if I unscrew that, let's just make sure the connections are getting through. Obviously the power's getting through. Let's check all the sockets in here first. I think that's a good start. So taking a look at this power panel, like it was fixed onto the side of the Keytar there. It's pretty dusty, a lot of crap. So now this power connector is free. On this circuit board, it looks like the two power inputs have been connected together. The DC power supply and the battery, and they're both connected here with this wire. When I snipped it, it actually stopped working. So I can only assume there's something wrong with the voltage regulator on the other end. I'll join it back together and investigate it a bit more closely. I have followed where this comes through onto this next board here, and well, you can see straight away there's actually a blown transistor there. I suspect that because that would be on the line from the power supply, that someone's plugged in the wrong power supply and blown that out. So that's why they shorted that ground side from the battery into that, so it's going to be going through to this transistor instead. So that's kind of solved that mystery. But as for the other issues, I guess it's just going to be a question of seeing if there's anything else blown. Often you'll see blown capacitors, like these electrolytic capacitors. Often if something's wrong, they will have swollen a little bit. Then you'll see that that would be, instead of a flat surface, it would be a little dome. So that's usually a really easy thing to tell. But I can't see anything else really obvious, unless when this transistor blew, it blew some of the other circuitry. But honestly, I think all this is doing is passing power along. And because the unit is definitely getting power, I'm not going to spend much more time on this circuit. I'm going to have a look at the next one instead. So as you can see, these circuits are pretty filthy. I'm trying to clean them up as best I can. There's just so much disgusting dust. It smells a bit like aftershave. I guess. There's a little bit of gunk around there. Maybe some sort of drink has been spilled into this at some point in its life. I mean, it's obviously been very well used. It's really dusty. I guess it is at least 30 years old now, so I'd be kind of astonished if it didn't ever have any drinks spilled in it. But yeah, it seems to have cleaned up a bit, but I wonder if that's a hint as to what could have damaged this, whether that might have caused some problems. So here's the main board for the Keytar. I've cleaned it up, and you can see pretty obviously there's quite a lot of corrosion around those chips, and I suspect that's probably what's causing us some of our trouble. And here's the main power board with the blown power transistor. It needs a bit more cleanup, but I'm going to leave this for now and take the rest of the Keytar apart, see what sort of state that's in before we investigate further. Pretty cool engineering going on there, I have to say. So this is quite interesting, because this is connecting to this kind of standoff here. I think this is actually meant to be kind of maybe welded onto there and has snapped off, and that's why everything's a bit loose. These presumably are coming from lights there, 9 buttons there. And then this here is coming from the keyboard. So at the moment none of that's working. If everything's broken, then it makes me concerned that the main processor could be damaged. I think it might be a bit dead. I'm noticing something, a bit of corrosion around this chip here, so it might be worth cleaning that up. Or I think these are fairly standard chips actually, so it might even be worth just replacing them. There's a bit of corrosion around this one too. Yeah, so I've learned a bit about this main board. It's quite, well, it's just a really complicated setup compared to the sort of modern electronics that I'm used to. You know, I could pretty much do all of this in a single Arduino type board. But yeah, what have we got? Well, these two go off to the LED banks on the front display there, and they're connected to a couple of chips that, you know, basically drive those LEDs from a digital signal. This is the input from the buttons on the front, which I've temporarily removed. Yeah, and these two go off to the controls in the, I don't know what you'd call it on a guitar. I suppose it would be called the neck. Headstock perhaps? I don't know. Yeah, no matter what I do, whenever I plug it in, I just get the bank and program lights lighting up at 1. So that suggests to me that whatever's driving those LEDs is working. This here is actually a ceramic oscillator or resonator, so that's providing the clock signal for this main chip, and this should be outputting a clock to this one, which does all the A to D conversions and all the various signals coming from the other chips from all the inputs. So I don't know, but I've got a sneaky feeling that if this is broken, this oscillator, then this chip won't be running well or at all. What I do have is a pretty good logic analyzer, so I might put that analyzer on a few of these pins to check that the clock is coming out. And there's also the MIDI output on this chip as well, so I can have a look at that MIDI output just to see if there's anything there. So what else? Well, I found this weird thing. I was investigating these switches. They're just micro switches, you know, momentary buttons. I've basically proved that this button just isn't working. As far as I can tell, none of the buttons are working. I'm quite surprised that such a simple mechanism has failed throughout the entire device. It's just, I don't know, it seems weird to me. I put the analyzer on the circuit in various places and I've discovered that actually the ceramic oscillator was working just fine. It was putting out a 4 MHz signal just like it needs to. So that 4 MHz signal is converted into 1 MHz by the main CPU, and it was that I traced into this chip here, which is a flip-flop circuit. So you don't really need to know too much about flip-flops, but this is a D-type flip-flop which can actually halve the frequency of a clock. And in this case, it was halving the 1 MHz signal into a 500 kHz signal. And as there are 2 flip-flop circuits in this single chip, the output of one of those is going into the input of the other. So this is actually working to reduce that frequency by 4. So it's going from 1 MHz to 250 kHz. I put my analyzer on that chip and it just wasn't chucking out the correct clock signal at all. So I decided to replace it. You can see that when I desoldered it, I actually replaced it with a socket so that next time if the chip fails, it'd be much easier to replace it. And that's a trick I learnt from the arcade cabinet fixing scene. So put it all back together, tested it, and still nothing was working. The buttons weren't working, the keys weren't working, the LEDs weren't changing. But when I tried the analog inputs, I was actually getting MIDI data out of the MIDI port. So that fixed a lot of stuff. I knew that the clock was working, the main CPU was basically working, the serial output was working, and the analog inputs were working, but just none of the digital inputs. Looking at the circuit diagram, all of those inputs go through this one chip. It's an inverting buffer, and when I put my analyzer on it, it didn't seem to be behaving properly, so I'm going to replace that, and while I'm at it, I'm going to switch up the electrolytic capacitors as well. Right, all plugged back in and ready to test. I'm going to switch it on and see if there's any difference. So those lights are a bit different. Program change still isn't working. Let's try this program bank selector instead, see if that's working. Yeah, nothing at all. That's really weird. It's just jumped one light to the right. It's really, really odd. Okay, well let's try replacing this chip with the original one. Make sure I haven't broken anything else. So that's the original chip, and it's back to how it was before, the first 2 LEDs. Right, so I've identified a couple of chips that look a bit suspect, and they're also feeding all of the digital inputs, and there are just a couple of non-inverting buffers. So I'm going to replace those out and see what happens. together, and just now when I tried the program change buttons, it actually changed the program, you know, the LEDs lit up, so that's very hopeful. I'm just going to try the keys. Nope. No, really getting nothing from those. Oh, now the program change buttons aren't even working anymore. I'm just going to quickly check to see if MIDI notes are coming out. Oh, yes! I'm getting MIDI notes. I'm not using the keyboard, I've just wired this up. That's brilliant. Let's see if the octave change works. Nope. Same octave. I honestly think I'm just going to have to change every single chip on this board. Well, it's been kind of a tough few days, I've got to admit. I mean, I really, at one point there, I just thought nothing was going to work, but we managed to get a few breakthroughs. Like, we've actually figured out now that the main processor is working. What else? We've got the MIDI output. We're definitely getting MIDI output. The keyboard inputs are working, although the actual keyboard itself is a bit not quite working. And the analog inputs, all of the volume, mod wheel, pitch bends, that's all working fine. What isn't working, none of the LEDs are right at the moment. And we also are missing a few of the buttons, the program change buttons and stuff like that. Now, I managed to find this service manual, which has been really helpful in trying to, oh, there's some brilliant pictures in here, look at that. Oh. Look at that exploded diagram. It's really helpful because it's a block diagram and also a schematic. So it's really interesting actually just to see the approach that they used to take on devices like this, because actually the CPU is kind of a general purpose chip and it's using all of these discrete logic chips all around it in order to get it to do the things that it has to do for this specific MIDI keyboard. So yes, I have the schematic, but I don't know if you can see it. This is a really terrible scan. It's so hard to see all the labels and stuff, and particularly the net labels are really hard to see. It's like really like a bad, poor quality fax machine copy of this. So I've been going through and just sort of relabeling all the various bits. Can you see this? There's one I've marked up that's full of like little extra marks and stuff. But kind of run out of time for this video. In the next video, I'm going to progress further and see if I can get the Keytar fully 100% working. So if you've enjoyed this video, please hit that subscribe button, hit the like, subscribe, hit the bell, do all that good stuff. And yeah, I'll see you in the next one. Hopefully we'll get a working Keytar.